right. So, I forgot 0 as well. What is the sign value at the ordered pair that lands right there on 0? What's the sign value? That's 0. Because that's talking about how high up it is, and that's 0 up. So at pi over 4, we go over X amount, but then we go up how far to get to pi over 4? That's radical 2 over 2. Now, we're going to be graphing this on the graph below, and on the y-axis, you aren't going to be able to find radical 2 over 2. So we need to decimalize it, we need to approximate it. So how would I find that decimal? Yeah, sure. Cut it in. Just go back to
all there is actual hand ways to do that.
No, I know. It's not that I don't like it. It's just we have to understand it. Radical 2 over 2. And then you think about like how accurate can you really be when you graph it. I think 0.7 is about accurate as we're going to get when we graph it. So about 0.7 is what radical 2 over 2 equals. It's about 0.7. Okay, at pi over 3, we're going to go over X amount, and then we'll go straight up. Pi over 3, what is the Y value? What is the sign here? Radical 3 over 2. That's another one that I have no idea what decimal that is, so type it in.
0.87.
How accurate are we going to be when we plot it? About 0.9. Are you doing 0.87? I can. I'm going to plot 0.9-ish. And then for pi over 2, we go straight up, pi over 2. What is our Y value there? How long is that? That's 1. So as we go through the first quadrant, as the thetas or the angles are getting bigger each time, what's happening to the length of my Y's? Getting bigger each time. Until we get to pi over 2, which is 1. That is the longest it gets, because now you can see visually that from here, it gets shorter, then shorter, then shorter, and then we're back down to 0 again. Let's put in these values as well. At 2 pi over 3, that's radical 3 over 2, but approximately what? 0.9, we've already written that one down. 3 pi over 4 is radical 2 over 2, which is approximately 0.7. 5 pi over 6 is a half. And then at pi is 0. So our Y values, as the angles get bigger, our Y values are getting bigger until we get to pi over 2, where it's the biggest it can possibly be. And then we get smaller again until we get to pi. What is our very next Y value at 7 pi over 6? Okay, so I've changed my color here. This is now negative a half. So it's a half in length, but it goes down in set. Then our next one is going to be, okay, I gotta stand in front of this sometimes for me to draw like really accurate stuff. So I will move once I've drawn it, but sorry. This next one's going to be negative 0.7, then negative 0.9, and then at 3 pi over 2, we are at negative 1. So in the third quadrant, what are the Y values doing? What are the Y values doing in the third quadrant as the angles get bigger? They're decreasing? Well, look at them. They're not decreasing in size, but what are they doing? It's hard to describe. So like the numbers are getting bigger, but they're negative, so it's going more and more and more negative.
Yes.
Okay. But you can see that they are, like the length of my lines, you can see that they're getting bigger. It's just that way bigger. Okay, and then once we hit negative 1 through pi over 2, that's the most negative it gets. From there, it's now going to get less negative, and the lines are going to get shorter each time. So we'll be at negative 0.9, we'll be at negative 0.7, and then at negative a half. And then we get back all the way around, and then we're at 0 again. 0 is not negative or positive. So. Now, do we only... Wait, what? You would never have a reason to write that. Okay. For what we're about to do. Alright, so okay, remember the angles are going counterclockwise, but once I get to 2 pi, should they ever get bigger than 2 pi? I could ask you what's the sign at 3 pi, and you'd have to go do-do-do-do-do-do. I could ask you what's the sign at 7 pi, and you have to go around a couple times. So, this sine function is what's called periodic, and it has a cycle where it repeats itself over and over and over again to infinity. Okay? But then also we learned that what if I went clockwise? Are the values going to be different if I go, are the values of sine going to be different if I go clockwise? No, but the thetas, if I go clockwise, the angles, what do they do? This would be negative pi over 6. This would be negative pi over 4. This would be negative pi over 3 if I were going clockwise around. So if we go the other way, it's just negative angles. But the sine values are all the same. So now what we're going to do is we're going to take these sine values and we're going to plot them on the graph. Now the graph doesn't have anything written on the y-axis, so I'm going to put right here at this first mark, I'm going to make that a half, and then this one I'm going to make 1. So down here, negative a half, and then negative 1. So we can do these decimals a little bit easier. And then on the x-axis, we have the angles, and then the y-axis would be the sine at that angle. So our first point is at 0, what? 0 for the angle, 0 is our y value as well, so 0, 0. The next angle, that, as we go around the circle, what's the next angle we get to? You guys have the circle in front of you. What's the next? Pi over 6. And I don't see pi over 6 here. What's the next one after pi over 6? Pi over 4 is next. And what's the value of pi over 4? 0.7. So pi over 4 is going to be exactly in between 0 and pi over 2, just like it is up on your unit circle. Pi over 4 is the 45 degree. That's exactly in between 0 and pi over 2. You're missing out on the first step. So at 0, I mean at pi over 4, it's 0.7, just approximate it. And then pi over 2, our value is 1. And then where pi over 6 and pi over 3 are, they kind of mimic where they are on the circle. If you look up here, you're thinking degrees. Like if this is 0 and this is 90, this one is 30, 45, 60. These are all like closer together, and these are a little bit further apart. So you're just going to approximate as good as you can that the 60 and 30 are a little bit closer to the 45s than they are to the 90 and the 0 on your graph down here. So I'll put those like about here and about here, approximately. So that is the first quadrant of the sine values. They are getting bigger each time. After we go to pi over 2, that's the highest that sine will be. That's the highest. It will never go higher than pi over 2. What's my next sine value? And what's next? 2 pi over 3. We're going around the circle, but I can't show my circle at the same time. What's the next one? After pi over 2, we're at 2 pi over 3. No, sine value at pi over 3. The radical 3 over 2 is what decimal? 0.9, and then we've got 0.7, right? So we've got a 0.9 next, and then we have right at a pi over, or 3 pi over 4 is 0.7. And then at 5 pi over 6 is half. And then at pi, it's back down to 0. So you can see the y values are getting bigger till they get to pi over 2. Now they're going back down to 0 in the second quadrant. Third quadrant is from pi to 3 pi over 2, and these are getting more and more negative now. So we're going to have a point at, well, 5 pi over 4 would be in between here, and that's at like 0.7. 3 pi over 2 is -1, and then I can fill in those other points from there. And then it's going to, in the fourth quadrant, from 3 pi over 2 to 2 pi, go back up again, get less negative. That is the sine curve. But remember, it is what I said, periodic. It cycles over and over again, the same numbers over and over and over again. So this here is one full cycle. One full cycle. Oops, I can't go. This here is one full cycle of sine. I'm going to use a color and highlight color in this. This is one full cycle of sine. And it should not look like a zigzag. It should look like a beautiful, smooth curve. That's one full cycle of sine. Can you see I put an arrow at the end because it goes on forever. But it also goes on forever to the left. We can go clockwise around our circle in the negative, so we're going to continue this pattern. This shape is going to repeat itself over and over again. If I look back up at my unit circle, and I'm thinking about going clockwise around, what is this angle clockwise? This angle right here, clockwise. That's 3 pi over 2 counterclockwise. What is it clockwise? In radian. Pi over 2 would be here. What makes it go there? Negative pi over 2. So if I'm thinking about going to the negatives, negative pi over 2 is what sine value? Should already know. This is the same as 3 pi over 2. What is that sine value? That's -1. Negative pi over 2 is -1. So we're going to continue this pattern. I'm not going to do all of this little stuff. We're going to continue this pattern to the other side. Well, actually, I can do all of this. I'm not going to do. So how many full cycles of sine do you see on this graph right now? 2, right. 2 full cycles. But it goes on forever. They should not look like zigzags. It goes on forever. So I have arrows at the other end saying this pattern is going to continue to infinity. the graph, which I've colored in a different color so you can see what I'm talking about, have a name. And you're going to have to find this when you do your assignment. That name for one full cycle is called the period. It's called the period because it's periodic. It cycles over and over again. Just like other things that have the same names. Over and over again. Correct. No joke. So the period is how long from start to finish. The horizontal length from start to finish is known as the period. The horizontal length of one cycle. So that's how long the period. When you have that down, let's see, we're not ready to learn more because we didn't fill out that chart. Don't turn the page. So what I'm going to say is, you do not have to graph every single little dot every time. I'm going to give you key points that if you graph these and you know it's supposed to look wavy, you can just connect it to key points and you should have a great graph every single time. So the key points that we're going to put are in that chart. You just have to know 5 of them. Not that much. First of all, what are the x values? What are the x values? Not numbers, but what are they? The angle, the thetas. So for my x values, my first one's going to be 0. And my last one's going to be all the way around at the end of the cycle, 2 pi. So that's pretty easy to remember. 0 and 2 pi are like the same. And then they're evenly spaced. So what's right smack dab in the middle? Pi. Okay? So what is, now these are evenly spaced, what's right in the middle of 0 and pi? Pi over 2. And what is exactly in the middle of pi and 2 pi? If you're not sure, look at your unit circle. What's exactly in the middle of pi and 2 pi? 3 pi over 2. So what I'm doing is I'm using the key points that are the ones that are from the quadrantals, the ones that are on the x and y axis. And what are those values? For sine at 0 degrees, sine at 0 degrees is, or 0 radians, is what's sine here. You have them written down already. 0. What's sine at pi over 2? 1. Sine at pi. 0. Sine at 3 pi over 2. Here 1. And sine at 2 pi. 0. So these are the key points. And if you forget, what, well, first of all, if you can remember 0 to 2 pi, you can find all of these because they're evenly spaced. If you forget what the sine values are, just like go to one of them on your unit circle. What is the sine at pi over 2? Well, that's the ordered pair 0, 1. It's got to be 1. Like you can come up with these later if you forget them. I always remember that sine is one that starts at 0. And then I just alternate 0, negative 1, 0, or 0. What did I just say? 0, 1, 0, negative 1, 0. Like I just memorize them. But you can come up with them as well. So these are the extreme sine values. They're right in the middle. It's the top, the highest sine value, right in the middle, the lowest sine value, and right in the middle. All right. Now we're going to do the same thing with cosine, but we can skip some of the stuff. Because cosine values have all of the same values as sine, just not in the same place. So they do have all the same values as sine. Yeah? Oh, okay. Well, you'll just want the cosine values on that side. Easy copies over. Okay. So the cosine values are similar to the sine values, like all the same numbers, just some of them are in different places. So let's quickly whip through these. What at pi over 6, what is cosine? Actually, I forgot 0. I'm sorry. Right at 0, what's cosine? 1. Now, I'm going to draw these as well. Remember cosine on the unit circle is what? Cosine is, remember sine is y, so cosine is x. So I'm going to draw from 0 horizontally, this is 1. So from pi over 6, we're looking horizontally. The length at pi over 6 is radical 3 over 2. I'm going to write the decimal. You already have radical 3 over 2 hopefully written over here. I'm going to write the decimal, which is about 0.9. Then at pi over 4, it is 0.7. And at pi over 3, the x value is a half, or 0.5. And then at pi over 2, we have an x value of 0. So what's happening to my x values in the first quadrant? They're getting smaller. They're actually starting at the biggest number it can possibly be. They're starting at 1, and then they're getting smaller. So once we get to 0, then what happens? What's my next, oops, I'm changing color now. What's my next x value? Negative a half. So now these are all getting more negative. So we get to negative 1. What happens at negative 1? In the third quadrant, what happens to the x's? Are they still negative or turn into positive? So negative, we're just getting small. So negative 0.9, negative 0.7, negative 0.5. Until we get to 0, then in the fourth quadrant, now my x values change back into positive. And they're getting more and more positive until we repeat the process again. Again, this is periodic. It has a cycle. How long is one cycle? From start to finish. How long is that? I didn't write that on the front page, did I? I just told you the definition. I didn't actually write how long it was. So we'll write it on this page. So the x values start at 0, and they go all the way around, and they end at what? Not the cosine, the angles. 2 pi. And then once it goes through 2 pi, that's when it starts repeating again. So the period for cosine is 2 pi. That's how long one cycle is before it repeats again. That's the same thing with sine. So if you want to write the exact same thing on your sine side, I'm going to write it. I'm just writing the exact same words, so I'm just going to say sine. I'll just write it down where we were talking about the period. So the period for cosine of x and the period for sine x is one full cycle, 2 pi. That's how many different values there are before it repeats itself again. So we're going to graph cosine, but I'm going to show you how we're going to actually do it. We're not going to graph every single one of those little points. It would be similar to doing it for sine. We're just going to use our key points. And the key points begin at 0 and end at 2 pi. And they are evenly spaced, so I know the middle one's got to be pi. They're evenly spaced, so I know the second one has got to be pi divided by 2. And this one has to be 3 pi over 2. Then I need to know the cosine at each of those angles. The cosine at 0 is 1. And we go to pi over 2 straight up. Cosine at pi over 2 is 0. Then at pi, cosine is negative 1. Then at 3 pi over 2, cosine is 0. And then back to the beginning again, 1. So it has the same values as the sine. It's just this one starts at 1. The other one started at 0. But they alternate the same values. So now we go to graph those. And I'm going to count by halves again, so it's easy. At 0, it's 1. Pi over 2, 0. Pi is -1. 3 pi over 2, 0. 2 pi is 1. And then I have to connect these with a nice smooth curve. That's going to be one cycle. Then we have to complete the pattern. So these will always go all the way up to 1 or all the way down to -1. They will never go past 1 or -1 unless we have a stretch. And they're going to complete that pattern. So since it's all the way up at 1, my next one is going to be 0. Then the next one's going to be -1. Then the next one's going to be 0. Then back up to 1 again. And we're going to complete that pattern. At the very end, it'll never go higher than 1. So you notice how my end arrows, I had them pointing down because that's where they would go next. So don't have your end arrows. This would be bad. Don't do this. Don't have your end go whoop. I would take it off if you do that at the end because that's not where the graph goes next. It does go down. So I continue that until I draw my arrow. Okay. All right. Turn the page. At the top, there's like, oh, just kidding. This is at the bottom. It's just vocabulary. You don't really have to write anything. But the amplitude, I'll show you with the graph. The amplitude is something you're also going to have to answer. The period we just talked about. Okay? Period we just talked about. Amplitude we haven't talked about yet. So when you have amplitude, you're going to have your sine or cosine graph. They all look the same. They just have different points. And the amplitude, the definition says, from the middle of the graph, they call that the midline. From the middle of the graph, if you take the value from top to very bottom and you multiply by half, you'll have your amplitude. So with our graphs that we just did, if I look at the very top number and the very bottom y value, how far are they apart? 2, but then you take half of that number, and the amplitude would be 1. It's half of how tall this is. But there's like this midline. If you just go from the midline and you say how far from the midline up or how far down, it doesn't matter. It's distance. It's positive no matter which way. How far we go, that is the exact same answer. That's what I like to think about. It's from the midline up or from the midline down. So if you use the book's definition, you just do it a different way. It's still the same answer. All right, and then there's some directions on how to graph these, but I'm not going to read this to you. You can read it later. We're just going to go through the steps. All right, ready? 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 Okay. Actually, before we do that, I want to show you a cool video. Let's stand up while we watch this video. And who's tall? This will be our first one. No. Can somebody tall go? But not so far that I can't close them. That's good. Okay. Oh, both of them. And then we'll open the door in just a second. But I want to show you a video that's really cool. But stand up so you're not like falling asleep. Nah. Okay, what this is this is a video that shows from the circle how the sine curve is made. So remember, the sine curve is made from the y values, those lengths up and down. Well, watch it. It's cool how it connects it together. It's got good music. Oh, you can't hear the music. Isn't that cool? And I go backwards too. And it's taking all of the y values, even more than we did. I'm going to repeat that. It's taking. Oop, I hit the wrong thing. No? You can. Tomorrow you'll be watching a video that's probably around that. Probably longer than that. So again, same concept. Taking the y values, making them into a nice smooth curve. There's your sine graph. There you get it. No, but I got another one we can play. Is a different one. Yeah. So this one is so trigonometry is like used all over. It's so important for like real life application. And if you do like music, you know, like you've ever seen music as what's that called? Like the wave, yeah, the waves. Those are like trigonometric equations, but they're just all different lengths and stretches, and it makes different noises. So if it's a shorter one, it's going to make a certain noise, or if it's a longer one, it's going to make a certain noise, or if it's like a wider one, it's going to make a certain noise than a skinnier one. So the wider and the skinnier have to do with frequency. And you guys know, like, humans, we can only hear between certain frequencies. Does it change with how old you get? Probably.
How old were you?
It's a minute.
I'm still staying.
Well, maybe we'll do that. Yeah, please stand. Stand hold on.
Oh, no, it's a song. It's a song.
Oh, my kids love that song. Anyway, so this is a frequency, but I guess it's a hearing test. But at the beginning, you aren't going to be able to hear it. There is something, but you aren't going to be able to hear it because it's so low that it's out of our range. Then all of a sudden, you're going to be like, "Oh, I hear it." Now, if you all start talking, nobody's going to hear it. So you got to be quiet. If you want to say, "Oh, I hear it," without making noise, then you go. Okay? Then it's going to get really, 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 really high pitched, and eventually it'll be like out of our hearing range, like a dog whistle. So all of a sudden you'll be like, "I don't hear it anymore," but you're not going to say that. You'll be like,
That was only three. Yeah, in the cafeteria.
okay. The sound is plenty high enough. At first, you're going to be like, "I don't hear it." Yeah, because you're not going to hear it at first. And all of a sudden, it's going to come to you. Ready? So it's gonna continue for a little bit, and then once it gets really high, then we have to really be quiet because it all of a sudden disappears. All right, should be gone.
You were at earlier than like I was.
Oh, this is a hearing test?
Yeah.
Oh, that looks exactly the same. Hey, but
But at the end, she was out early.
oh, that one maybe on our brain break. But what was happening to make the sound go higher? What was happening to these waves? What is that called when we graph graphs and it goes?
Shrink.
What kind?
Horizontal.
Horizontal shrink. Horizontal shrink. Good. All right, so we're gonna graph. We're now going to graph our first transformed sine function. We've already graphed sine. And you can see at the very top it says we're going to graph 4 sine x, right here, 4 sine x. Okay? And I don't have a lot of space to write, so I'm going to go down here for a second and write. There's these understood parentheses around the x. You don't see them unless they have to be there. But that is anytime we have any sort of horizontal transformation, they'll be there with the x. Okay. It will be after the word sine, and it'll be either in parentheses or just right there after the word sine. It's going to be horizontal. And you'll see some different examples today. If it is in front, or if there is, right now there's just +0 out there. If it's in front or if it's at the end, adding or subtracting at the end, that's going to be vertical transformation. And we've been doing transformations since section 1.1. So we've been doing these a lot. And I can go kind of fast through these other than the new stuff is now with a sine graph instead of with a y=x² graph. When I have horizontal transformations, do I use the exact numbers that are written there?
Yes.
No.
It
It was a 50-50, but we have to know that. What if in there I had like x plus 3? What would you actually do? You would subtract 3 to the x's. What if I had like a half out here? What would you actually do? You wouldn't multiply by half. What would you do? You wouldn't multiply by half. What would you do? What's the opposite of multiplication? Division, but I'm not going to divide by half. So instead of dividing by a number, we multiply by its reciprocal. So instead of multiply by half, I multiply by 2. Remember these rules? Do the y's use different numbers? No, the vertical ones are just like if it's multiplied by 4, then you multiply by 4. If it's adding 0, then you add 0. You don't subtract it. That doesn't change it. Okay. So we're going to start by saying, all right, these x and y are my key points for the parent function. So remember, the x's are always 0 through 2 pi, and they're evenly spaced, so we can space them evenly. If we forget, just half them all and space evenly. The y's, these are sine x. So now I either know what the sine x at 0 is, what the sine at 0 is, or I have to like think about my unit circle and go to 0 and write my ordered pair and say what sine. What is it? 0. And then at 2 pi, I'm not 2 pi, pi over 2. 1, and then it's 0, and then it's -1, and then it's 0. Every other number is 0. You just have to know if it's 1 or -1 after that. Okay, then we look here, and here's our equation, 4 sine x. So is that 4 a horizontal or a vertical? A vertical what? So your a transformation, when you describe a transformation, you do a vertical stretch by a factor of 4. So in my table, I'm going to multiply which values by 4? Vertical y. Look how easy those were to multiply. So now I graph my outermost x and my outermost y. I'm graphing 0, 0, pi over 2. By the way, these are now new graphs. They're kind of squished together more. They're like zoomed out. They go 0, 0. Pi over 2 is 4. Pi is 0. 3 pi over 2 is negative 4. 2 pi is 0. That is one cycle. But then you have to continue the cycle until it goes off the graph. So you have to follow the pattern correctly until it's off the graph. It does not seem like it should be hard, but people make mistakes, so practice it. Make sure they don't look like zigzags, because now we don't have all those other points. Remember how smooth they looked before. Try to make them look smooth, even though we're only doing some of the points. I can't get rid of this topic. There's like nothing different. I don't have a cold or anything. I don't know. So they put me on like some medication to get a little help in the next couple days. Make sure your graph looks like mine, because I'm literally looking at some papers and they don't look like mine. So make sure yours looks like mine. And then the arrows. Now we have to write the amplitude in the period. Write the amplitude in the period. So the amplitude is from the midline, which I think you can see where the midline is. We didn't have the directions say graph it. I don't really graph it, but from the midline, how far up or how far down is it stretched? 4. The amplitude is 4. And conveniently, that is part of our transformations as well. It is the vertical stretch, because that's what makes it do this. It is always the vertical stretch. Yeah.
Since something goes down, why would it be like plus or minus?
The amplitude is length. So how long from the midline is it? 4. It doesn't matter if it's going up or down, it's 4. Okay, now the period is how long horizontally one cycle is. So I purposely made one cycle a different color. From start to finish of one cycle horizontally, how long is the period? What length is that? 2 pi. Remember I said for sine and for cosine, the period is 2 pi. There's only one thing that will change the period. Well, here's one of my graphs. Do you see my graph? The only thing that can possibly change the period would be something that makes our graph do this. Watch, ready? Or something that makes our graph do this. What am I doing? What kind of stretch or shrink? Horizontal stretch or shrink is the only thing that will change our period. So if we don't have a horizontal stretch or shrink, still 2 pi. Which we didn't for this one. Alright, moving on. So the next one should be 1/2 cosine 2 pi. What do we have next? 1/2 cosine 2 pi. Okay. So we're going to look at our table and we're going to fill out our key points for cosine. And our x's are the angles, so 0 to 2 pi. And then they're evenly spaced. So 2 pi, or pi is the middle. Pi over 2 up here. 3 pi over 2 down here. And then the cosine we have to think about what is cosine at 0. This is the ordered pair 1, 0. What's cosine? 1. And then at pi over 2, what's cosine? 0. And then at pi, cosine is negative 1. And then 0. And then 1. It's alternating with 0 and negative and positive 1. Now let's look at our transformations. We have a half in front. What's that half going to be? In front. What's that half going to be? That's vertical. So if it's vertical, do I change the number? So it's going to be vertical what? Shrink. Thank you. It's between 0 and 1. It's a shrink. I factor of a half. That means I'm going to take my y values and multiply by a half. And then what's the 2 going to do? What's the 2 going to do? It's going to multiply by half. So that's going to be a horizontal shrink by factor of half. Hey, I'm recording here. Your person. So we're going to multiply our x's by a half because the horizontal ones we flip. So how do I multiply pi over 2? Multiply that by a half. Those are fractions. How do you multiply fractions? We took a test on every time. Somebody probably don't know. How do you multiply a fraction? Straight across. So we get pi over 4. How do I multiply pi by 1/2? You put pi over 1, you multiply straight across. Pi over 2. How do you multiply 3 pi over 2 by half? Straight across. 3 pi over 4. 2 pi times a half. 2 pi times a half. Pi. My y values will have 1/2, 0, negative half, 0, 1/2. So we'll be graphing the outermost values. Let me give you some hints about these. Because they're all evenly spaced, even if you don't know where pi over 4 is, you should be able to figure it out. What I'm going to do is I'm going to graph these first. Because those I have on that graph down below. I'm going to graph the 0, the pi over 2, and the pi. I'm going to graph those first. I have 0 1/2. Then I've got at pi over 2, negative 1/2. And then at pi, I'm at 1/2. So these are evenly spaced. So if I can graph 0 and pi over 2, where's pi over 4 got to be located? They're evenly spaced. If I've graphed 0 and pi over 2, where is pi over 2 or pi over 4? Right in the middle. And then I look over here, it's got to be a 0 right in the middle, so I know where to plot that, even though I didn't have a pi over 4 on my graph. So same thing with 3 pi over 4. That's not on my graph, but I've already plotted the 2 around it. So you just find the exact middle of those and put the y value at 0. So this is one cycle. Then we continue the pattern until you're off the graph, positive and negative. And draw your arrows at the end. Next we're going to do is write the amplitude and the period. So if you're already ready, once you think about what the amplitude and the period would be, some people don't graph as fast. If they look like zigzags, then that's not right. Make them look curvy. I like it curvy. A horizontal structure shape which we have. So I'll show you how to do that. Well, this one would be from here to here. I didn't know what you meant. From there to there.
What?
Something crashed everybody does. Alright, so the amplitude. The amplitude has to do with how far above and below it is from the midline, which you might not know the midline, but I think you can look at it and figure it out. But it's also the vertical stretch or shrink. So what was our vertical stretch or shrink? Or how far is this up or down from the middle? Anybody? Okay. That's your amplitude. And the period, we're talking about how the period doesn't change unless we have a horizontal stretch or shrink, which we have. So the period has to do with the x values. So you take 2 pi, the original period, and whatever you multiply your x's by, multiply 2 pi by also. So we multiplied all our x's by half. Take 2 pi and also multiply that by half, and you will have your period, which is pi. And then if you look at the graph, and we go from start to finish horizontally of one of our cycles, it is pi long. But sometimes it's hard to look at the graph to figure it out, so this is how I always do it. I always just take 2 pi, multiply by whatever I multiply by x is. Okay? So there are some student practices, and you're going to see if you get it. I'm going to pause the video and I'm going to let you work for a little bit. And I'm going to take some good ones and display them. And I will reward you if I display yours. Okay? We will after we do these 4 student examples. So I'm displaying the answer to number 1. Hopefully you had enough time to go through number 1. And I'll pause it up here so that if you are still finishing number 1, you can still see it. But you should be on number 2 by now. So here's the answer for number 2. And yeah, it's probably a little messy as well. But the answers are correct. It's just a little messy. Maybe a little spelling. So here's number 3. They are really close together. They are really close together. You just keep drawing down. This is coloring patterns. You guys can do that.